Hi students, so today you are going to be watching two videos, and this is the first video on reflection. And as you watch this video, it's really important that you take notes. As we go along, I suggest either you write them on a separate sheet of paper or you print out this document and then follow along that way. Okay, so we're going to start off with what is a reflection. Right, and reflection is one of the three main forms of transformations. You've probably seen it several times in the real world, right? Looking into a mirror. When you fold a piece of paper, right, you get something on the other side. Things like that. Okay, so we're going to take a look at this diagram, and in this diagram, this shows us an example of triangle ABC. So this triangle right here, we're going to label this as the pre-image, right, being reflected across the or in the x-axis. Okay, or actually, I'm sorry, this should say not the x-axis, but this should say the y-axis, because what's happening is you're reflecting across this line right here. This is our line of reflection. So if you imagined this on a piece of paper and you were to fold your piece of paper along this line, this yellow line, your shape would end up on the other side. So this image, this is the pre-image, this would now be the new image, right? So if we're looking at our points, A is -3, +3, but now A prime is 3, +3. B prime, right, is now going to be 2, -1, and C prime is going to be 1, +4. So all that's really changing here is my xy is now going to become the -x, and y is still going to be the same if you look at the rules, right? In terms of our segments and our angles, right, those don't change in length and size, so these do not change. And this makes sense because, again, this shape is undergoing a rigid transformation, but it's not changing shape or size, it's just being reflected, in this case, across the y-axis. Okay. If we scroll down to here, again, this is just more of a definition, but one thing I wanted to highlight is if your point or your shape is anywhere on the line of reflection, right, it's just going to remain on that line of reflection. So again, if you have, this point A, right, if you reflect it across the line I just drew, you should have A prime here, right? But if I'm asking you to reflect this point B, right, well, it's not going to reflect on either side because it's on the line, so this would still be B prime. Okay, so that's one thing I did want to highlight to you, but I will, if you want to pause this video and just kind of read through this aspect of it more formally, you can. Okay. So the next thing I just kind of want you to fill in is this page of notes, which I will go through with you, right? So right here, this coordinate AB, you can think of that as the original or the OG, right? These will be the pre-image. Image. So what we want to do is we want to just label, we're going to label A, B, and C. So A is at -3, +4. B is going to be at -3, +1. And C is going to be at 0, +1. Okay, now the rule is if we're reflecting across the x-axis, then this is going to be A, -B. Okay, so our new image, if we apply this rule, x is still going to be the same, but now we're going to make this, our y values, negative. So -3, negative 1, and C prime is going to be 0, positive, or I'm sorry, not positive, negative 1. Okay, so if I plot these points, I should get negative 3, negative 4, B, and then C right here. I should get this image. So this will be A prime, B prime, and C prime. And this makes sense because we are reflecting over the x-axis, and the x-axes are going to be right here. Okay, looking at the next one, I'm reflecting over the y-axis. Now the y-axes are going to be right here. Okay, so if I reflect this, right, just drawing it, I know that my shape, this point is still going to be here, so this is actually also going to be C prime. And then since I'm 3 units away, I need to measure out 3 units away, and then 3 units up, so this is A prime, B prime, C prime. I connect my dots, so this is going to be negative A and B. So I'm just going to go ahead and fill in my coordinates. So I know that A originally started off at negative 3, positive 4, and if I apply the rule, I should get 3, 4, and I'm going to go ahead and just fill in the rest of these here, because again, these are where the locations of the coordinates are located. Okay, so reflection over the origin. So remember, the origin is going to be right here. It's 0, 0. If I were to fold, this piece of paper, right, I'm going to reflect it down this way and then across this way. So if I reflect it across the origin, so my triangle should end up right here. So this will be this is going to be C prime, this will be B prime, and this will be A prime. So this will be this right here if I am reflecting across the origin point. And again, the rule for this is, now this is negative A, negative B. So I'm going to go ahead and fill in my coordinates as well. And I'm actually going to leave you all to finish filling in those coordinates. And for the last one, we have y, reflection over the line y equals x. So this is kind of where those algebra skills come into play. And I need you to think back, well, what is y equals x? Remember, y equals x is this straight line that goes through the middle of the graph right here. So there's this line. And what happens is when we reflect across this line, we think of it as folding a piece of paper, right? We'll have our triangle is going to end up somewhere over here on this side, but we want to be precise, right? So what happens is, or what the rule is going to be, is we're actually just going to switch our A and B coordinates. So again, we have A, B, and C. Our coordinates for A are negative 3, 4. B is negative 3, 1, and C is 0, 1. So for our image, again, for A prime, we're just switching the values around. So 4, negative 3, so now this is A prime. B is going to be 1, negative 3, negative 3, so this is B prime. And then C is going to be 1, 0, which is going to be right here. So this is C prime. So here is our triangle. Okay, and this makes sense because if we zoom in just to show you this distance from here to here and from here to here, that's the same. This distance from here to the line is the same as this distance from the line to here. So again, it's really important that you not only apply these rules correctly, but that you are reflecting as accurately as possible. And remember, this rule right here only works for this line, right? It doesn't work for like y equals 1/2 x. That's a totally different line. So that does not work for that line. Okay, so this is it for the video for part 1. You are going to watch a second video on dilation for part 2.